continue for this tutorial. So how are you going to fit this second order model? Okay, so to fit the second order model, basically first thing I need to clarify that in the exam, in the final exam, I will be asked you to do it manually. Because if you want to do it manually, then that one is they deal with the big the big dimension of the matrix. Okay, so to get the following equation, if okay, the concept of the getting the equation will be here. You need to estimate the parameter of all these here. So in this model, they consist of all these parameter. So the estimated parameter will be equal to the x okay. You need to get the following. If you do it estimate parameter, this one is what I have told you before in the linear regression, where you need to have your x matrix and then the y matrix here. So the y the y here is already you have it. The x here you need to write the first one will be the 1. Then after that the second one will be the -1. -1 until the rest of them until the 0. This one is all for the x1. Then after that you have a x2 is a -1 and then 1 and so on until the last one is 0. This one is the second. The first row is a 1. All the value is must be 1 because they want to take care about first the first parameter estimate. Then after that x1 the column here. And then after that, because you want to fitting the model with the iteration with the square term, so therefore the third one, you need to do the product of the x1, x2 yourself, so that you get the value. This one times this one, you get the value 1. This one times this one, you get the value -1, and so on. This one times this one, you get a 0. So you get another column. Another column is x1 square. x1 square. x1 square is this one is square is 1. This one is square is 1. This one will be 0. After that, the following one will be the x2 square. Then the x2 square is here is a 1. Here is a 1 and so on. The last one is 0. Yeah, you need to get the following matrix of the x first. And then if you deal with this matrix, you can see that the dimension of this matrix is consists of 1, 2, 3, 4, 5, 6. You have a 6 row, 6 column. Then how many row? You have here is a 4 plus 4, 13. You have a 13. So this one is the 13 row, and then you have a 1, 2, 3, 4, 5, 6 columns. So this one is 13 times the 13 times the 6. Okay, the dimension is the 13 times 6. So this one is of course you will not do it manually. So if any of you have let's say you have any of the statistical software, SPSS, or if you know how to put all this value in the matrix in the R, then you can do the calculation, then you can get all the estimate out. Okay, but this type of the thing, I won't be asked you to do it during the final exam, unless it's assignment that is possible. Okay, so after that, you can estimate all the parameter here. Okay, all these parameter will be here. Will be similar to here. And then of course, we can test the significance for each one if you learn the linear regression analysis. But in our course here, we only stop until how to estimate the parameter of the second order models. Okay, we are not going to learn further about the linear regression. Okay. So this one, the first one is actually I use a regression analysis command in the Minitab. I get this answer. In the Minitab, they also have another one. It's called response surface regression. Then if I do it, I select all the model at once, I still get the same answer. Okay, the answer is same, just the position order. This one is A square, this one is B square, this one is AB. But I put the AB here, X1, X2 is AB. So actually they are the same answer. Okay, so this one will refer to your the question number 11.8. Similarly, for the question number 11.10, also we have given you this one. Okay, we want to fit the second order model. So this one is a second order model, similar work you have done. But the second one is you need to know. Because after you get this second order model, then we need to know the nature of this second order model. Whether this thing is the minimization problem or maximization problem, or you get the point is called the shader point. Okay, so for the part A, of course, if I given the equation, then you definitely can do the part B. That one is called canonical analysis. So we try to use the eigenvalue to solve it, to find the stationary point, and then we try to group this point is whether it's minimized or maximized, or the shader point. Okay, so that one is using the eigenvalues techniques. Okay, so based on, let's say you already get the following equation, then you need to know that you go back to this chapter, you can know that what is your B. The notation of the B will be equal to this one is the value for the factor itself, only the single factor here, then it's a 5.33, and then this one is a 1.73. This one is a vector of the B, and then you also have another one is a capital B. The capital B, the diagonal will be your quadratic terms, so it's a 4.2. Here is 9.53. Okay, the off diagonal, you use the iteration, the coefficient of iteration divided by 2. So it's a 1.15 divided 2, 1.15 divided 2. Okay, you can refer back the notes where you need to get these two. So to get the stationary point, same like the question show you the stationary point here. How to get the stationary point? You get the small letter of B, the vector here, and the matrix here. Then you know that XS will equal to minus half B inverse B. This thing is I have shown it to you how this formula is come from. Okay, so you just multiply the inverse matrix, but the 2 by 2 matrix, I think is possible for you to calculate out. Okay, even though the 3 by 3, you can use a calculator to do it. But when you have a 4 by 4, all these things, I would not ask you to do the calculation manual. Okay, so the 2 by 2, 3 by 3, I think is still possible. Okay, so you use this B and then the inverse of this matrix, then you can get out the SS. The SS is a stationary, the stationary point will be equal to negative 0.6276. The second one will be negative 0.053. Okay, you will get this one. So using this one, you can get what is a stationary point. And then you also can be further know that under this stationary point, you will lead you, for this equation, will lead you to the maximize or the minimize. Or you have another one is called the shader. They cannot identify as a maximum or minimum. So that one, you need to know the eigenvalues. You need to know their eigenvalues of here. So for the nature of the point here, then you need to, for the part B, I will put here. For the part B, you need to find out the B minus by lambda I equal to 0, the determinant here. So because you already know your metric of the B just now I have given it to you. The capital B will 4.2, 9.53. Then this one is a 1.15 divided to 1.15 minus by the lambda. I is the identity matrix 1001 equal to 0. Okay, so means that you are finding the determinant of this matrix 4.2 minus the lambda. The second one should be this one 1.15 divided 2, you get the 0.575. This one also 0.575. Then the following one, this one minus here is 9.53 minus by lambda equal to 0. Okay, so the absolute is a determinant. So therefore, you just solve the equation 4.2 minus lambda minus 0.575 square equal to 0. Okay, this the determinant is just a cross product out here. Then you will get the quadratic equation. Okay, you solve for this quadratic equation, you get your lambda is equal to 9.59. Another lambda will equal to 4.13. So this one will showing you here 5.53 and 9.59 here, 9.59, and then lambda is 4.13 here. Okay, of course the value is 138 because I have rounded the decimal places. Okay, here. Okay, so once you have it, both of them positive. So this one will be the you will get your minimum of your response. Okay, so this thing, all these things you can see it from your lecture notes. Okay, so this one is about for the tutorial 8. How do you get your get the equation? Of course, you can try for this one to get your equation using the similar technique as just now, or you want to have a software, you also can do that. Okay, so this one is your tutorial 8 about this thing. Okay. So for the next next week, what we are going to do, first thing is I will be discuss with you about the test 2, about your test, about your test 2. The second thing is I will show you the partial question, okay, to show you how do you want to perform, because some of you, I think not some, many of the student is not from the before that the first degree is not from the University of Malaya. Therefore, I will show